In the previous episode, we learned that Jupiter is not only the largest, but also the most massive planet in our solar system. This fact gives it an exceptionally powerful gravitational field, capable of attracting countless moons. And indeed, their number is staggering. At the time of recording this episode, the existence of 67 such celestial bodies has been officially confirmed. However, the exact count depends on how small an object must be to qualify as a moon. In 1610, Galileo Galilei pointed his telescope toward Jupiter and witnessed a true scientific revolution. He spotted 3 tiny stars aligned near Jupiter. Unlike ordinary stars, they moved and were invisible to the naked eye. A week later, he noticed a 4th star and realized he was observing objects orbiting Jupiter. This discovery became crucial evidence that the solar system does not revolve around Earth. In Galileo's honor, these 4 moons are now called the Galilean satellites, a remarkable achievement for just 1 week of meticulous observation. These 4 moons are impressively large. Were it not for Jupiter's overwhelming glare, we could see them with the naked eye, and might even have classified them as planets. Jupiter's largest moon is Ganymede. With a diameter of 5,270 kilometers, it is the biggest moon in the entire solar system, larger even than Mercury, placing it between Mercury and Mars in size. But size isn't Ganymede's only planetary feature. It's composed primarily of rock and ice, yet scientists suspect it harbors a liquid iron core that generates its own magnetic field. Ganymede's surface resembles that of our moon, displaying both ancient, heavily cratered terrain and smoother, younger regions. It's also crisscrossed by enormous grooves. The origin of these grooves remains unclear, but they may result from tidal stresses caused by gravitational interactions with Jupiter's other large moons as they orbit and approach one another. Beneath Ganymede's surface lies another astonishing secret: oceans of liquid water. Measurements of its magnetic field by the Galileo spacecraft in the 1990s, along with observations from the Hubble Space Telescope, strongly suggest the presence of a salty, subsurface ocean. As we see later, this feature is not unique to Ganymede. The second largest moon is Callisto, with a diameter of 4,800 kilometers. Like Ganymede, it's composed mostly of rock and ice. Scientists believe it has a rocky core overlain by a mixed layer of rock and ice. Much of its surface is icy, but blended with dark material. Callisto also possesses a magnetic field, though its core is likely not made of iron. Its surface is densely cratered and shows no signs of volcanic or tectonic activity, indicating it is extremely ancient, possibly as old as the moon itself. Callisto has an atmosphere, but it's exceedingly thin. Its atmospheric pressure is just 1/1,000,000th that of Earth. It orbits Jupiter much farther out than the other Galilean moons, about 2 million kilometers away. This distance is sufficient to influence its siblings when it comes to mutual gravitational effects. The other 3 moons are noticeably affected by Callisto. Next is Io. Slightly larger than Earth's moon, Io orbits very close to Jupiter, completing 1 revolution in about 1.5 days. When Voyager 1 flew past Io in 1979, its images revealed a bizarre surface, painted in yellows, oranges, reds, and blacks, with no obvious impact craters. Engineer Linda Morabito noticed on one image what appeared to be another moon partially hidden behind Io. But it wasn't a moon at all. It was a volcanic plume erupting from Io's surface, arching high into space. Io is the most volcanically active body in the solar system, hosting over 400 active volcanoes. Many erupt simultaneously, so even images taken months apart show dramatic surface changes due to ejected material. Much of this material is sulfur-rich, which explains Io's vivid colors. This intense activity is powered by the other moons. As they orbit, their gravitational tugs stretch Io, heating its interior through friction. Much of the sulfur eventually forms a thin atmosphere around Io. Jupiter's powerful magnetic field then captures these sulfur particles as Io orbits, accelerating them to high speeds. This process has created donut-shaped radiation belts around Jupiter, similar to Earth's Van Allen belts, but far more intense. The radiation is so concentrated, it could kill an unprotected human in just minutes. Of course, if you were drifting unprotected near Jupiter, radiation would be the least of your worries. There's more. Ganymede and Io are magnetically connected to Jupiter. Charged particles flow from both moons along Jupiter's magnetic field lines and collide near the planet's poles, much like solar particles interacting with Earth's magnetic field to create the auroras. On Jupiter, this produces spectacular polar auroras. You can even observe ultraviolet glows where these moons are magnetically linked to Jupiter's atmosphere. Now let's turn to Europa, the smallest but most intriguing of the Galilean moons. Slightly smaller than Earth's moon, Europa has long been known for its highly reflective surface, indicating the presence of water ice. However, observations by the Voyager spacecraft brought unexpected revelations. Europa's surface lacks craters, suggesting resurfacing from below, similar to Io or Venus, but without volcanic activity. Most striking are the intricate networks of cracks, long linear bands, and complex ridges. These features appear to be formed by material welling up from Europa's interior, much like lava shapes Earth's surface. But here, the material is water. Scientists believe Europa harbors a vast subsurface ocean beneath an icy crust several kilometers thick. The movement of this water shifts the ice above, creating the observed surface features. The total volume of water may exceed that of all Earth's oceans combined. Like Ganymede and Io, Europa's core remains warm due to tidal heating from gravitational interactions with neighboring moons, keeping the subsurface water liquid. Here's another fascinating detail. Much of Europa's composition consists of silicate rock, similar to Earth and other terrestrial planets, lying beneath the ocean. If this rocky layer interacts with the ocean, as it does on Earth, the water could be salty. Notably, the dark streaks on Europa's surface are rich in salts and organic compounds, carbon-based molecules. This is profoundly exciting. Life on Earth is thought to have originated in salty ocean water. If Europa's ocean contains carbon-based molecules, it's not unreasonable to wonder whether life might have emerged there as well. Scientists believe Europa possesses all the key ingredients for life, though we still lack direct evidence. Some researchers have proposed sending a spacecraft to Europa to search for living organisms. The idea is to land near a thin ice fracture and somehow penetrate the crust, perhaps by melting through it, to collect chemical samples and look for signs of biological activity. The possibility of life on Europa, even microbial, is now a serious question for astrobiologists. What was once science fiction has become legitimate scientific inquiry. Astronomers use the concept of the habitable zone, the distance from a star where a planet's surface temperature could allow liquid water. But this concept is somewhat misleading. Venus and Mars lie within the Sun's habitable zone, yet Venus is too hot and Mars too cold for liquid water to exist on their surfaces. Atmosphere plays a critical role. Still, the habitable zone remains a useful general guideline. Europa, however, has challenged this idea. Jupiter is far outside the Sun's habitable zone, yet Europa holds abundant liquid water. This is a powerful reminder that we must allow our ideas to transcend the boundaries we've set. When searching for life on exoplanets, we must consider possibilities we never imagined before. These 4 large moons, each thousands of kilometers in diameter, are thought to have formed alongside Jupiter, coalescing from swirling material in the disk that surrounded the young planet billions of years ago. But Jupiter has dozens of other moons. The only thing they share is that they are gravitationally bound to Jupiter, each completing an orbit around it. Jupiter's tidal forces are hundreds of times stronger than Earth's, so strong that it's no surprise they dominate their surroundings. The largest moon beyond the 4 giants is much smaller, Amalthea, an irregularly shaped body 250 kilometers across, discovered in 1892 and coated in sulfur from Io. It orbits just 100,000 kilometers above Jupiter's cloud tops. If you stood on Amalthea, Jupiter would fill half the sky. Beyond it, moons grow progressively smaller and more diverse. Himalaya, Thebe, Ilara, Pasiphae, and even tiny ones like Hegemony, Calichor, and Callirrhoe, some no larger than hills. Many of Jupiter's distant, irregular moons orbit in the opposite direction to the planet's rotation, so-called retrograde orbits, suggesting they may be captured asteroids from nearby belts. Several moons share nearly identical orbital characteristics, hinting they were once a single body that later broke apart. These fragments now orbit Jupiter as families. The smallest moons we've observed are just 1 kilometer across, barely large enough to ride a bicycle on if they were on Earth. But in orbit around Jupiter, they're scarcely more than debris. Thousands of house-sized objects circle the planet, and who knows, there may be millions the size of tennis balls. Should we classify them as moons? Perhaps, but that's not what matters. What's important is remembering that each of these worlds, great and small, is astonishing, rich, and diverse. And we still have so much to discover about them. Today's exploration has revealed the extraordinary realm of Jupiter, a celestial giant surrounded by a multitude of moons, among which 4 colossal bodies stand out. These moons are primarily mixtures of rock and ice, yet Ganymede, the grandest of them all, boasts an iron-rich core. Io appears as a volcanic world, scarred by hundreds of active eruptions, while Europa conceals a vast ocean beneath its icy shell. an ocean that has become a focal point in the scientific quest for extraterrestrial life. Io, Europa, and Ganymede, orbiting in close proximity, engage in a unique gravitational dance that heats their interiors. Beyond these giants, Jupiter hosts numerous smaller moons, about which we still know very little.